Imagine a world so close to its star that a year lasts just over 2 Earth days. A place where winds tear through the atmosphere at over 5,000 miles per hour. A place where molten glass forms in the sky, then rains sideways, slicing across the horizon like tiny shards of a shattered mirror. And the planet itself? It's blue. A deep, electric cobalt that glows like a gemstone in the void, but not because of oceans. This is HD 189733b, one of the most extreme and violent exoplanets we've ever discovered, and the more we study it, the stranger it becomes. In 2005, astronomers at the La Silla Observatory in Chile detected a faint but regular dip in the brightness of a star named HD 189733, located about 64 light-years away in the constellation Vulpecula. Every 2.2 days, like clockwork, the star would dim slightly, then return to normal. What they were seeing was the shadow of a planet, one nearly the size of Jupiter, passing in front of its star. The planet was named HD 189733b, and it quickly became a favorite target for scientists. Why? Because it was unusually close, unusually active, and unusually perfect for study. Years later, the Hubble Space Telescope was used to capture something no one had ever measured before: the visible color of an alien world. What Hubble found was stunning. HD 189733b wasn't gray or cloudy like many gas giants. It was blue, not just blue, but vivid cobalt, like Earth's oceans seen from space. But this planet is no paradise. With temperatures soaring to nearly 1,800 degrees Fahrenheit, any water that once existed would have been long gone. The blue hue comes from something far more alien: tiny silicate particles suspended high in the atmosphere. These particles scatter blue light the same way our atmosphere makes the sky look blue. But on this world, that atmospheric beauty is only the beginning of something far more dangerous. Under intense heat, those floating silicates begin to behave strangely. They condense into droplets of molten glass. And once they form, they don't fall gently to the ground. They're caught in the planet's fierce winds, which scream across the atmosphere at more than 2 kilometers per second, roughly 5,400 miles per hour. That's 7 times the speed of sound. The glass rain doesn't fall straight down. It gets whipped sideways, turning the atmosphere into a furnace of flying blades. These conditions aren't speculative. They're based on real data collected by the Spitzer and Hubble space telescopes, which detected both the silicate clouds and the massive atmospheric wind speeds. It's weather that makes Earth's most violent storms look like a gentle breeze. HD 189733b is so close to its star, just 3% of the Earth-Sun distance, that it's become tidally locked. That means one side of the planet always faces the star, basking in perpetual daylight, while the other side remains in endless darkness. The result is a dramatic temperature difference, over 1,000 degrees Celsius on the day side, and still blisteringly hot, around 500 degrees, on the night side. But the most remarkable part is how that heat moves. A massive jet stream flows around the equator, carrying energy from the hot side to the cool side in a process called superrotation. Think of it as a global conveyor belt of hellish wind, moving faster than anything on Earth. It's one of the most extreme examples of atmospheric circulation we've ever detected on any planet. You might wonder how we know so much about a planet we can't even see directly. The answer lies in light. First, there's the transit method. When the planet passes in front of its star, it causes a tiny but measurable dip in the star's brightness. This tells us the planet's size and orbit. Then there's transmission spectroscopy. As starlight passes through the planet's thin atmosphere during transit, different gases absorb specific wavelengths, leaving behind a spectral fingerprint. That's how we know what the atmosphere contains: water vapor, traces of methane, silicates. But there's more. When the planet moves behind its star, we briefly lose its infrared light. By subtracting what we see before and after, we can isolate the planet's own thermal glow. That reveals its temperature and even lets us map the heat distribution across its surface. HD 189733b was the first exoplanet where all three techniques were used together, turning a tiny shadow into a fully realized alien world. So why spend so much time studying a planet we could never visit, where glass rains sideways and the sky glows with heat? Because planets like this help us test the tools we'll eventually use to find habitable worlds. They teach us how heat moves in alien atmospheres, how clouds and haze scatter light, how unexpected chemistry creates surprising colors, and they remind us that appearances can be deceiving. Just because a planet is blue doesn't mean it's Earth-like. HD 189733b may be a furnace of shattered glass and fire, but it's also a stepping stone toward finding calmer, potentially life-bearing worlds in the vastness of space. And the story isn't over. The James Webb Space Telescope is already turning its eye toward HD 189733b, using advanced infrared instruments to look deeper into its atmosphere than ever before. Early results hint at even more complexity: carbon monoxide, perhaps even titanium oxide clouds. The upcoming European mission, Ariel, will study the atmospheres of 1,000 exoplanets using methods we pioneered here. And Earth-based telescopes like the Extremely Large Telescope will soon be powerful enough to map cloud systems and weather patterns on distant worlds. We're not just learning to detect planets, we're learning to understand them, to watch their weather, to read their chemistry, to explore their atmospheres without ever leaving Earth. HD 189733b may be one of the most violent places in the galaxy, but it's also one of the most useful. It helps us sharpen our instruments, test our theories, and prepare for the day we find something gentler, something more like home. So the next time you hear someone say, "We've found a blue planet," remember, not all blues mean oceans. Some blues mean storms of flying glass. If this journey into deep space sparked your imagination, hit that like button, subscribe for more stories from the universe, and share this video with someone who still thinks space is empty. Keep looking up. The truth is out there, and it's more astonishing than we ever imagined.